Hello Eng 1060. In this video, I will be going through pseudocode. So what is pseudocode? Pseudocode is an informal description of what your code intends to do. It allows programmers to express their logical steps in a readable format prior to coding. It forces programmers to organize their thoughts and also allows others to check your logic before you start your coding. There are 5 major components for pseudocode. They include variables, assignment, input and output, conditions, and repetition. Thinking ahead or writing pseudocode reduces the amount of errors and hurdles during the programming stage. So let's consider the following example where we are checking whether a student has failed or passed. Referring back to our 5 major pseudocode components, we have variables. In this case, we have perhaps the student score, the assignment of it, which is perhaps an input prompt, input and outputs being perhaps an fprintf of either fail or pass, conditions, so we're checking whether the student score is less than or greater than 50. And in terms of repetition, for this particular scenario, there is no repetition, so there are no for loops or while loops that is anticipated. Writing out the comments, we can see that we have our initial variable being score. If score is greater than 50, then we'll print pass. If it's lower than 50, then we'll print fail. Converting this into actual code, we have our same comments, and then we begin filling in the different comments with our MATLAB code. So our score variable is input via an input prompt. We can then use an if statement. If score variable is greater than or equal to 50, we can print pass. So this is the fprintf. Else if score is less than 50, we can print that the student has failed. Notice that in the pseudocode, I have used keywords such as if and print. This will allow an easier transition from pseudocode to MATLAB code. Taking a more complicated example, suppose that you will be able to deposit the following monthly amounts into a savings account, which pays 3% annual interest compounded monthly for a period of 5 years. The account initially has no money in it. So for the first year, our monthly deposit is $300. For the second year, our monthly deposit is $350, and so on. At the start of each year, you withdraw $3,000 to buy a certificate of deposit, also known as a CD, which pays 6% interest compounded annually. So our task is to write a MATLAB program which computes the amount of money that we will have at the end of 5 years. So that's a total of our savings account plus our CDs. There are a few assumptions that we need to consider. You will deposit money in the savings account on the first of each month. Savings account interest is paid on the last day of the month. You withdraw money from the savings account to buy the certificate of deposit on the first day of each year. And your CD interest is paid on the last day of the year. So as with any complicated or complex problem, we need to start by writing pseudocode. Again, our 5 major components are variables, assignment, input and output, conditions, and repetition. We can write the pseudocode in an M file using comments. So I first need to initialize my variables, which I have identified as savings, CD, and monthly deposit. I then need to do some calculations with my savings account, needing a loop for my years because there are different monthly deposits depending on the year. But also I need to loop for my months because my interest is compounded monthly. So there are 2 loops that I can foresee. I also need to deduct the CD at the end of each year. That's for my savings account. For my CD account, I need to calculate the interest on the CD account over years 2 to 5. As a final step, I can then envision that I will add the total savings and the CD accounts together. So I can first initialize my variables. I have savings, which starts off with 0. My certificate of deposit is 0. And my deposits for each year is given by a vector. 300, 350, 400, 450, and 500, given by the table above. I can then move on to the next portion of the pseudocode, where I am repeating a pattern of code for the 5 years. So I have 4 year equals 1 to 5, meaning that the code will repeat 5 times. I then need to think about what is happening within these 5 years, or within each year. Well, within each year we have 12 months, and therefore I need to think about what's happening within each month. Within each month, I can calculate the interest that is accrued on my savings. So this is my current savings plus the monthly deposit. This calculation is repeated 12 times before it exits the for loop. So then what happens after each year? We need to subtract the withdrawal required to purchase the certificate of deposit. That's given by savings is equal to savings minus 3,000. So at the end of the first year, it subtracts the $3,000 so that we can purchase our CD. Then it will run back up here and the year will change to 2. Month will restart back at 1 and repeat the same calculations for 12 months before again subtracting 3,000 at the end of the second year. So assuming that our savings account is correct, we can then move on to our CD account, which is the next portion of our pseudocode. With the certificate of deposit account, we need to calculate the interest over years 2 to 5. So this likely means that we will need a for loop. So we have 4 k equals 2 to 5. Our certificate of deposit is equal to certificate of deposit plus 1.06, which is our interest rate, multiplied by 3,000. Finally, we are left with adding the savings and the certificate of deposit accounts. We can do so by saying that the total savings is equal to savings, which was our value up here, plus our cash deposit, which was this value here, plus 3,000. The 3,000 here comes from the unnecessary subtraction at year 5. So at the end of year 5, we have minus 3,000 from our savings account to purchase another CD. However, this was not mentioned in the question, and therefore we need to re-add the 3,000 at the end for our total savings. It's minor things like these that is unlikely to be picked up during the pseudocode planning. and therefore it is crucial that we validate our code as a final step. So in order to validate our code, we can run the code to ensure that there are no syntax errors. If we encounter any errors, then we need to first address those. If MATLAB then provides you with an answer, we need to justify it. Does it look correct? If possible, we should check the answer against any analytical answers that are available to us. Or we can use different tools, for example, plotting the data or the results to see if they're valid and feasible. If the numbers look incorrect, then we can begin to debug our code. And I'll talk more about debugging in a future video. So in summary, engineering problems are often too complicated to code on the fly, meaning that we need to write pseudocode to organize our thoughts and allow us to plan in an effective manner. And also it is important to review your code once you have written it, as not all of the scenarios are thought out during the initial stage. As a final thought for this video, is there a difference between comments and pseudocode?